Okay guys, so in this video we're going to be talking about graphing linear inequalities, but we're doing more than one. So when you guys have more than one, either equation or inequality, it is technically called a system. So when you have a system, it means that you have more than one equation or more than one inequality. So in this little graphing system of inequalities, because they're going to give us more than one, in this case just two. So to graph a system of inequalities, let me just refresh your memory on one of the videos that I did in the past. We basically have to know how to graph a line, first of all, which I hope you guys all know how to do. If not, look at one of the other videos. And you have to know some of the rules. You have to basically know 3 rules in addition to graphing a line. One of the rules is if you have a less than or a greater than symbol, so either less than or greater than without the line under it, you're going to have a dashed line, meaning that we're not including any of the points on the line as part of the solutions. The other rule is if you have a line under it, we're going to be connecting the dots with a solid line, meaning that we are connecting or including all of the points on the line as part of our solution. And then the very last rule is if the alligator or Pac-Man eats the variable y, we shade upwards. So shade above or up above the line. Okay, so that being said, I'm going to do an example with you guys, and then I'll do another one in which you have to solve for y, so you guys can refresh your memory on that. So let's do this one on the left hand side first. I'll come back to the rules in a little bit, so just we're going to focus on these guys right there. So we have 2 equations, which I'm going to color code for you guys so you guys can see which one's which. So the first one is y is less than 1 over 3x plus 1. Okay, so we have that guy. And then we have another equation that we want to graph. Y is less than or equal to negative 2 over 3x plus 2. So this is called a system of inequalities because we have more than one. We actually have 2. So we have to graph both of those on the same graph. Okay, let's take it one step at a time. So forget about the one that's pink for now. I'm just going to worry about the one that's green. So the y-intercept for the one that's green is 1. So on the y-axis, I'm going to start at the positive 1. So I'm going to put a dot right at the positive 1. Because the y-intercept or the starting point is the one without the variable every single time. So starting there. Then the slope is the number that's in front of the x. In this case, the slope is 1 over 3. It's positive, so that means I have to go up 1 and to the right 3. 1, 2, 3, and there's my second point. So I have my 2 points. If you connect those 2 points, you get a line. But be very careful because you have to go back and look at the rules real quick. You can't just draw a line right away because we have an inequality. So the inequality rule says that if you have a less than or greater than symbol, you're going to have a dashed line. So if I go back to this specific one, the green one, notice that there's no line under it. So we're going to have a dashed line for this. So I'm going to connect it, but I'm going to connect it with dashes. Now what that means is that we're not including any of the points on the line. So if they were to ask you, is any of the points on the line a solution, you would say no. Okay. So let's see where we have to shade for this. So in this case, it says we have to shade below. How do we know that it's below? Well, because if the alligator or the Pac-Man eats the y, we shade up. If the Pac-Man does not eat the y, we shade down. So in this case, it's not eating the y, excuse me, so it's going to be down. So I'm going to go ahead and color this so you know what this line belongs to in terms of the equation. And I'm going to go ahead and shade downwards. So this is all the solution region for my graph. Okay, so as of right now, so if we're looking at just the green one, any point up here is not a solution to the green one. Any point on the line is not a solution to the green one. But if it's below this line, this is considered a solution to the green one. All right, let's deal with the pink one now. So for the pink one, we're going to start at positive 2. So on the y-axis, always, with the one without the variable, we're going to start at positive 2. Then we're going to go down 2 over 3 because the slope is negative 2 over 3. So starting here, we're going to go down 2 spaces to the right, 1, 2, 3. Let's make another dot. And then we're going to connect the dots. Before I connect them, is it going to be solid or dashed? If you look at the little line under it means we're going to have a solid line. So connect it with a solid line. So let's do that. I'm going to go ahead and color it. So this is supposed to be pertaining to the pink line. And then lastly, is the little alligator eating the y? Yes or no? In this case, the answer is no again because it's facing the other way. So We're not shading up because it's not eating the y. We're actually shading below the line. So we're going to be going back to the graph and shading below the line. Notice that those two shades overlap in a certain section. This certain section is actually the solution region to both inequalities. So since a system is more than one, we say that this region is the solution region for the system of inequalities. So now, again, if they were to ask you, is any of these points a solution to the system? You would say no. Is any of these points a solution to the system? You would say no. It actually only works for the pink one, not the green one. Are any of these points a solution? Well, no, that only works for the green one, but not the pink one. So these points, or this region, is actually the one that actually works for both the green and the pink, which means that this is the solution region for the system of inequalities. So we call this the region of solutions to the system of inequalities. Okay, that being said, the only other thing they might give you guys to try to mess with you or try to trick you or whatever is if you guys have something like this. So if you guys have a system of inequalities, but basically they give it to you in terms of standard form and not slope-intercept form, all that means is that you have to do a little bit of extra work to get the y by itself, which we've done before you can graph it. So I'm going to go ahead and color code it again. So one color, one the other color, and you basically have to figure out how to get the y by itself for the pink one, figure out how to get the y by itself for the green one, and then at the very end, once it's all said and done and you got that, then you can graph it. So I'm going to go ahead and do the work like, let me do it on this page since I'm not using it for anything else. So I'm going to rewrite it. So 3y plus 6x is less than 12. That came out of the first one. So, and I'm going to need a little bit of space, so hopefully you guys have a little bit of space to get the y by itself. So, okay, I'm moving everything to one side except for the y. So I'm going to draw the wall for right now. So I'm just going to get this out of the way for now. I'm going to draw the wall. Subtract 6x on both sides. This goes away. We're left with 3y is less than negative 6x plus 12. Notice that I did not combine these two because this one has an x and this one doesn't. So just write them over. Next step, we got to divide by 3. Divide by 3, divide by 3. We get y is less than negative 6 divided by 3. I have to divide both of these guys by 3. So negative 6 divided by 3 gives me negative 2. So I'm going to go ahead and just write that, negative 2x. If I divide the 12 by 3, I get 4. So I'm going to write plus 4. So this is my actual slope-intercept form equation, or inequality, I should say, for the first one that I could actually graph. Really, really important here. Notice that I divided by a positive number. When I divide by a positive number, the inequality stays the same as in the beginning of the problem. So we're good on that. If we were to divide by a negative number, then it's going to have to switch. Okay, let's do the other one real quick. So we could actually graph it. 3y minus x is greater than or equal to negative 3. So we're going to get the y by itself. Again, I usually like to draw a box around the y so I don't get confused. Draw the wall or line down the equal sign. I'm going to do plus x on both sides to get the y by itself. Drop the 3y. We get 3y is greater than or equal to x minus 3. Again, I don't combine these two, I just rewrite them. And then lastly, I divide by 3. So if I do this side by 3 and divide this side by 3, I get y is greater than or equal to 1. There's a 1, by the way, in front of the x that they don't really write. So I'm going to go ahead and just put it in there, just so you guys know where that comes from. So 1x is, so therefore I have 1 over 3x minus 3 divided by 3, we get 1. So this is my second equation that I could graph. Again, just like the last problem, notice that I did not divide by a negative. So since I don't divide by a negative, I do not switch the symbol in the inequality. So it stays the same. If I were to have divided by a negative, I would have to switch that, and it's going to change the region in which I have to graph the inequality. Okay, so all this work just to be able to graph this darn thing. Well, welcome to math, so deal with it. So I'm going to go ahead and just write these problems on the side so you can see them. So y is less than negative 2x plus 4. The other one was y is greater than or equal to 1 over 3x minus 1. All right, I wrote them. Cool. This is gone. Bye. Okay, so that first one was the solution when I got the y by itself for the pink one. That second one was the solution when I got the y by itself for the green one. So now let's actually graph it. So if I graph the first one, so this just becomes a problem just like example number 1. If I graph the first one, I start at the 4, so 1, 2, 3, 4. The slope is negative 2, which I can write as negative 2 over 1, so down 2 to the right 1. Check real quick, are we going to have a solid or a dashed line? Well, it doesn't have the line under it, so it's going to be dashes. So I'm going to go ahead and connect those with dashes. And again, this is the pink one. And then finally, do we have to shade above or below that line? So we have to check, is the little alligator or Pac-Man eating the Y? No, it's not. So if it's not eating the Y, we shade below the line. So this is going to be the solution region for the pink one. Okay, we got to do it again one more time. So this time we're going to start at the negative 1 on the y-axis. So it's going to be down here. And then we have to go up 1 over 3 because the slope is 1 over 3. So starting there, up 1 to the right 3. Let's check real quick. Are we going to have a solid or a dashed line? So the little line is under it, so we're going to have a solid line. So connect those with solid lines, or one solid line, I should say. This is pertaining to the green line. And lastly, is the little alligator eating the Y? Well, yes, it is. So in this case, we shade above the line. So we're going to be shading on this side. Okay, know it is that the overlap of the shadows or the shading is actually going to be in this section. So the solution region that satisfies both inequalities or the system of inequalities is this area right here. So this is the solution. So the solutions lie right there. So if they were to ask you, is this a solution to the system? You would say no, that only works for the green. Is this a solution for the system? No, that actually doesn't work for neither of them. Is this a solution to the system? No, that only works for the pink. Is this a solution to the system? You would say, heck yes, because it's on the line and the line is solid. We're including the line, so yes. Is this a solution to the system? You would say no, because the line is dashed. Dash means we're not including any of those points, so that'd be a no. Is this a solution? Yes, that works for both of them. So hopefully that makes sense as to what solution regions mean for a system of inequalities. Hope you guys have a good day, and I'll see you guys in the next video. See you later.